Counting down, we're going live in 3, 2, 1. Hello, everyone, and welcome back to Real Time Talk with Eagle 3D Streaming. I am Quentin Anderson, the host of the show, and today we have Ben Cahill, Innovation Manager at Doll Living Lab, also known as We Build Denmark, and he has a background in R&D from the software and academic business development domains. Currently, he is engaged in building a digital foundation for Europe's largest outdoor living lab with a focus on data interoperability and AI applications. He enjoys working with impactful technology that can make a difference for people. Ben, thank you so much for joining us today. How are you doing?
I'm very well, Quentin. Thank you for having me.
Yes, thank you so much for joining. I can't wait to get into your story, into everything that you're working on. So first, it would be great just to hear a little bit more about your background and how did you end up getting to where you are today?
Okay, so I am originally from Scotland and I've been living in Denmark since 2002. And I was educated here in Denmark in something called meteorology from Aalborg University. And that's kind of similar to what you have with modern technology development at somewhere like MIT. So it's essentially working with problems and using technology to solve problems. And it's a mixture of applied science, technology development, cognitive science, essentially trying to understand the user's needs and how do you address them through technology. And so after I graduated from there, I worked in the software industry for a couple of years. And then I went back to working in academia, where I was primarily running laboratories. First of all in the IT university here in Copenhagen, and then in Denmark's Technical University in their business incubation center. And there I was working with a lot of startups, spin-outs from researchers and so on, trying to help them mature and accelerate their technology. So working very much with AI applications, especially computer vision, embedded computer vision, blockchain, anything to do with data processing or cleansing or generating insights from data, and essentially running workshops and helping students to understand what are the tools that are available and how do we use them. Then since June last year, I joined Doll Living Lab here. And just to make a small correction to what you said earlier.
Yes, please.
So Doll is a part of a national cluster organization called We Build Denmark.
Okay.
And in Denmark, we have 13 of these cluster organizations, and the purpose of those is to encourage public-private partnerships and initiatives. So we are very typically running projects where we will involve universities or knowledge partners, private companies, municipalities, public organizations, around some kind of theme where it's very much focused on the green transition, improving the quality of life for our citizens, and generally trying to have a kind of European-centric approach to, for example, AI development. And what I do here primarily is that I work on everything to do with our digital infrastructure and data. So I work to onboard device owning or supplying partners into our data aggregation layer. I help to partner companies with knowledge institutions so they can begin to look at new applications for their technology or to explore new technological avenues. And we have also what we call a visitor service. So I'm also here meeting guests, taking them around the lab, discussing their needs, and we're also going out to conferences and trying to spread the agenda of how valuable it is to have a facility like Doll in your country.
So what was the interest or how was it transitioning from the academia space over to Doll? Are you finding that it's still fairly academic in nature, or is it more, or what's been your experience with this transition?
That's a really great question, and I'll give a slightly maybe controversial answer. So my experience working in the academic space was that the projects, products, services that are being developed there are often quite some way from the market. And it's not necessarily because there's no understanding of the market, it's that we're maybe making a lot of assumptions about how ready is the market and how ready are individual employees, cities and so on, for cutting edge technologies, because although it addresses their needs, it doesn't necessarily take their skill set into account. So on the one hand there in academia, I was seeing a lot of very sophisticated projects being developed in the lab and then trying to come out to the market and not being able to get traction, to get those first 100 or 1,000 customers if you have a digital platform, or to not be able to come out and do some proper testing out there. And then here in Dall, I think what we represent is we're kind of like a middle step between the more experimental technologies and the market. So it's a semi-scaling environment. And what I would say here is that there's very much a focus on the technology must be extremely robust and reliable. So if we think from an AI perspective, the applications that are being deployed here might seem reasonably old-fashioned in the sense that the cutting-edge AI in traffic systems, for example, is doing vehicle segmentation. And that was something, we were doing on command line 15 years ago, offline, right? But that's a kind of new thing, and it's an important thing here. So it's like my expectation was, I think it's also a presumption on my part, right? That I wasn't necessarily aware of how important it is to have this robustness and reliability at the expense of having the cutting edge innovation in the public space. So that, I'd say, it was my experience. But at the same time now, we also run a lot of projects with academia, and I'd say an advantage that I have is because I have some experience on both sides, that I'm able to hopefully balance out the needs from both sides.
Got it. So primarily addressing the needs of the market, but still a toe or two into the academia space.
Yeah, exactly.
How do you know that Denmark, that Europe is ready for this digital transformation now? What is it about the robustness and reliability? Obviously that's important, but how do we know that they're ready for some of these initiatives that your team is undertaking?
Well, I'd say, like, if I speak specifically into Denmark, right, that's what I can speak about. Denmark is one of the most digitized countries in the world and in Europe in terms of our public services. So the majority of Danish public services are online or through an application. There's a lot of independence among people, high degree of vehicle ownership and so on, kind of maybe centrist to left-leaning political stance. So people are willing to adopt new technologies and to try them out. And that's what's been happening for the past, 15, 20 years in Denmark. Traffic systems, anything to do with like the unemployment system, also like shopping online and all these kind of things have really been very quickly adopted. And of course, we also have things like GDPR, so the European General Data Protection Regulation, which is a European set of regulations that protect individual rights about sharing personal data. We have what's called the AI Act, which is about transparency within AI applications. And we're also coming up very shortly is going to be the European Data Act. So there's a lot of political impetus on the part of European politicians to lay the groundwork for a fair and transparent adoption of AI going forward. And if we look around at the kind of university spaces and research institutions in Denmark, there's also a lot of very valuable research coming out there in the AI perspective that's not necessarily brute force. If you look to, for example, China, you can see they are very much ahead of the game in terms of AI, but at what cost, right? And I would also say in America, my understanding is the data protection laws in America are opt-out. So you find out that your data is being misused, you have the right to contact that person, and then they will scrub you from the database.
Yes.
And in Europe, it's the other way around, right? So a company needs to ask your permission or get your consent in order to handle your data. And the thing is, now that we're currently working on our digital twin, we're primarily focused on infrastructure and buildings. So not really taking people into account. But of course, as these solutions get more sophisticated, so you can see people coming in and out of buildings, driving from point A to point B, you can infer a lot of activity just from these data, right? So it's very important for us going forward that we have this fundament of safety and security and transparency that's going to allow us to build valuable applications.
Yeah.
So I think, and I would say also, like if we compare it to US, a lot of young people in Europe have the opportunity to go to university for free, or college or trade school or something like that. And they're also getting, computers are pushed in at every level of education in primary and secondary and school. So we have a very computer literate and savvy population that are not particularly thinking twice about, for example, using route finding application to do holiday planning or something like this. It's just a very natural thing for them.
Right. So we're forward thinking, but we're not doing it in an irresponsible way. We're thinking about data protection and we're thinking about responsibility in every step. And another thing that I heard you say is, especially when we're talking about Denmark and the digital twins, infrastructure and transportation, can you give us maybe some specific examples of ways that you are digitally or using digital applications to improve infrastructure and transportation?
Yes, I can. I can share a couple of slides.
Great.
And talk a little bit informally about that if I can see how to share my screen.
Yeah.
I want to share desktop. I have to give that permission to do that. But in the meantime, I'll just try and talk about this while I'm doing this. So, in the lab, you can think about Doll Lab, Living Lab, where we are is a kind of microcosm of a city environment. It's 1 times 1.5. Oh, I can't share my screen because I haven't given permission. I need to restart to do that. So I'll just talk.
Okay.
So we are a microcosm of a city environment. So we're 1 times 1.5 kilometers. So we have a school, a nursery, we have factories, we have residences, we have public transport, and we have commuters coming in and out every day. So one of the challenges that we have in the lab is, or let's say in the world, is how can we reduce the impact of emissions from heavy goods vehicles? And one way that we can do that is by creating what's called a green wave. So a green wave in a traffic sense is when you prohibit vehicles from having to slow down for red lights when it's not necessary. So we know that when a diesel engine, you have like a 10-wheel truck, when that needs to accelerate from stationary to 40 kilometers an hour, it burns approximately half a liter of diesel. And it also spits out a lot of carbon monoxide and particles into the environment. So it's important that we try and avoid this deceleration and acceleration curves all the time. So the way that we do that is that we have smart intersections. Smart intersection is very typically an intersection where you have a camera, which is looking down, detecting, segmenting various types of traffic, and then sending messages down to the system that controls the traffic lights. So this could be, for example, that we recognize that this is a large truck, and then the system looks in the other directions and sees, is it safe to open up for green in the direction where the truck's coming from? And if it is, then it allows the truck to pass through without any interference. An extension of this idea is that we have an integration with our national bus operator. So the 2 bus lines that run through the lab, they are all the time constantly sending information to the bus operator's cloud, which tells them where the bus is and how far behind or ahead of schedule it is. And then this information is relayed down into the intersection. So the intersection knows, okay, bus 172 is 30 seconds behind schedule. So we want to provide an opportunity for the bus to catch up on that time. So that's a quality of service thing primarily for the bus operator. But what it also means is that we are avoiding these deceleration and acceleration, particularly when we're at a bus stop and we expect there to be people standing, waiting for the other bus line, or it's just part of the city environment where people are walking forward and back and forth all the time. So we want to avoid as much as possible putting those particles into the air.
So the primary or one of the main focuses is reducing emissions, but at the same time, it's improving our experience because I'm hitting less red lights.
Yes, exactly.
And then one of the overall objectives, especially with buses, is to hopefully or ideally reduce the number of stops just to the bus stops and prevent the bus from ever stopping at a red light.
Yes, that's exactly right. So the ultimate, like the kind of like the absolute best case scenario will be that you can have a circle bus route, for example, that only ever stops at the bus stops and never has to stop anywhere else. And then the bus driver can, manage the scheduling by controlling the speed. And you could essentially, if you were able to maintain a constant speed, then you would never have to think about having to catch up or slow down.
And then so these sensors that are at these intersections, they're able to detect whether it's a car, a bus, or a truck. Is that it?
Yes.
Then once the detection is made, it'll make a decision on whether or not we should change behavior, red from green, or just if it's maybe a car, it can stay red in case a bus is coming the other way.
Yes, and it can also be much more finely granulated. So if we are, for example, able to look up the number plate of the vehicle, we can find out if the vehicle is a combustion engine or if it's an electric engine.
Cool.
Because that could be something that's very difficult to see just visually, because a lot of car manufacturers now they will make a hybrid, an electric, and combustion of the same model, which look identical from the front. So the idea with this would be that you could create, for example, a dynamic exclusion zone. So in our school area, for example, where we have a main road and we have a lot of logistics companies. So there in the morning, there's a lot of goods being transported in and out. So there's a lot of heavy goods vehicle activity on the road. We can say we have a dynamic exclusion zone for heavy goods vehicles from 7:30 to 9, and then again from 3:30 to 5 in the afternoon. And we could combine that with maybe like some flashing lights or a variable messaging sign that says, turn around or get out of this area immediately, or even as an extension of that, collaborate with the enforcement agency to give fines. And I know that they're doing that now in some other European countries when truck drivers need to report the number of kilometers they're driving through a given country with the weight of their load, because they need to pay tax for the road damage. And people try to cheat on this because it's either manually reported or they have the opportunity to turn off their internal tracking.
Okay.
So what they do now is they have these ANPR cameras along the highway that are logging, when is truck X where, how long has it been since it was at the previous location, so therefore what's the average speed it's been traveling and how far has it gone, and so on. So it's a mixture. It's quality of life, it's quality of service for the operators, and it's also what would we call that, like law. We don't do law enforcement, but I know there it is being applied to law enforcement.
And do you think the Danish culture itself helps adoption of some of these more forward-thinking, efficient ideas?
I think, to be perfectly honest, I think it remains to be seen how happy Danish people are going to be about camera systems. So there's a lot of discussion now in the world of sensing about what we before called cameras and what are now called visual sensors, because you can essentially, with AI, you can extract more or less any kind of parameter from a camera that you're able to do cognitively with your eyes and your brain.
Right.
So we can replace a lot of existing like radar, LiDAR technology, for example. We can do what they can do in a camera, and we can also do 100 other things for the same price. So it makes a lot of sense to install a camera where instead of installing 4 different types of sensors, but we don't have this very widely distributed camera system. We have it on the motorway, and the motorway, they expose the data publicly, so the road director exposed the data publicly, but it's very tightly bounded by rules. So for example, you could only get access to the last image from any camera. You're prohibited from saving or downloading any images.
Cool.
And the images are extremely low fidelity, and all of the license plates are blurred. So the only real application that you as a kind of amateur AI developer could do with these images would be to say, is there congestion on this stretch of road or not?
Awesome. So there is a anonymization component of it. with the data itself to help maintain the integrity of data protection. So
yeah, exactly.
So we've talked a little bit about how we're maintaining and improving traffic through intersections and improving emissions. What about lighting? Do you have any ideas for how lighting is also being impacted through this digital twin transformation?
Yeah, so I myself am not a lighting expert, but DOL was originally started as a lighting laboratory, and that's actually what the acronym stands for, or stood for, Danish Outdoor Lighting Laboratory. So maybe 15 years ago, there was a movement to make a transition from incandescent lighting to LED lighting, because it's much more energy efficient, approximately 80%. You can make a saving, right? And then, of course, because we were changing out the armatures and so on, there's technologies that allow you to install sensors into your lighting infrastructure, so that you can dynamically dim your lighting up and down, for example, when there are pedestrians or when there are vehicles and so on. So one of the most important public infrastructure projects that there has been in Denmark has been this transition to LED lighting, and that has strictly been in the case of energy consumption and reducing the need for us to waste energy lighting areas that we don't need. And this is where our streaming platform, our pixel streaming platform, comes in. So we had developed an open world VR or a 3D model of the lab with photon space simulation of lighting. So also volumetric effects, weather, and so on. And the idea with this is to demonstrate the aesthetic impact of these lights. So one thing is that when we went from the tungsten lighting to the LED lighting, a lot of people said it doesn't look the same. It's flickering, the frequency is too low, it's too blue, and so on and so forth. And they would have to come out to the lab in the evening and see us turn on the lights so we can show them how this looks. So now what we can do in the virtual environment is that we can show this without having to do that. We can do simulations. For example, we can make an integration with a camera system that does accident detection. So there's a car accident, for example, on a road. We get a message, and through our connection to the traffic light, we just put all of the traffic lights red, and we make a call to the emergency service with the geolocation of the accident. And then we can make the lights flash red and blue, so that we think if there's anyone in the area that can help, or just to give a message, something is happening right here, maybe someone can come and help.
That's so cool.
So we also did a project together with the Technical University about biodiversity. So we know from lab experiments and from observation of city environments that LED lighting specifically has a negative effect on the feeding and breeding cycles of insects and rodents, birds, for example. And especially if it happens in insects, it has this knock-on effect. So the insects don't feed, they don't breed, the birds don't have anything to eat, the rodents don't have anything to eat, and then you end up with a city area which doesn't have any natural life. So the Technical University, they developed a special type of diode, which to our eyes, it looks white. So this is what's called tunable white, or natural white light. But if you were to look at the spectrum of it, it has a big dip in the blue. And normal white LEDs don't have that. They're normally quite blue. And it's this specific blue frequency that goes in and disturbs the brains of these primitive creatures and stops them from being able to, find a partner or find something to eat. So we've deployed that now down on one side of the lab. And that's something that will take many years or decades to validate. But it's already been validated in laboratory setting. We know the impact of this. So for us, it's very important to show the public that yes, we're putting all of these high-tech installations into the public space, but we're also thinking about nature and people and lifestyles and so on.
Yeah, because and to clarify with the audience, when I think about lab, I think of an enclosed place, beakers, Bunsen burners, and all that. That's not DOL, obviously. So what can you just describe the Doll Lab. From what is that?
So I would say if you were standing in the middle of the lab, Doll is more or less indistinguishable from any industrialized city area. So it's just outside of Copenhagen. It's 1 by 1.5 kilometer space. We have 6 intersections, 2 bus lines. We have approximately 11 to 12,000 vehicles going across our busiest road each day. And we have a number of technologies installed all around the lab. So cameras, IoT devices, that are measuring and monitoring various aspects of city life. And then we are accumulating all of these data. And this is our ongoing project now to build a digital twin. And then the idea with this is we will then expose these data through some kind of interface to application developers, software developers and so on, that allow them to build prototype applications that are applicable to people that live in cities. So for example, it could be like a journey planner where you can optimize after the greenest journey or the cheapest, the fastest or whatever. And because we're able to pull all of these different data sources together, because we also have a mandate from the city to install all of these devices and to get data, we're able to very quickly go from an idea to a test or an execution of the idea and to see is this going to work in real life, and then help these businesses then to scale their technologies out to larger environments.
Yeah, so this is a real city area integrated within Denmark that real Danish people are going and interacting in, and it's serving as space for training, simulation, testing, prototyping. How unique is this lab compared to other labs that you're familiar with in Denmark and Europe? Is this one of a kind, or how did Doll become to be?
It is quite unique in the sense that it's permanent. So when we run a project, so for example, last year we finished a project on intelligent traffic systems, and in a typical lab setup, when you run a project, you have your 3-year bounded time. You do your project, your experiment, you write everything up, and then the project leaves and everything's dismantled. So the difference with Doll is that each time we have this project, the technology stays in the lab, and we use the technology or the data to feed into further projects. So what we don't do, and we also have organizations in Denmark and Europe, like technical institutions, where you can come with your product and you can have that tested. So you might want to test, is your device waterproof, for example, or is your data pipeline GDPR compliant? We don't do that. So we don't take. You can't pay us to test your technology. What you pay us to do is to install your technology in the lab and then to demonstrate it for the kind of people that are going to want to procure this type of technology. And Doll grew out from, as I said before, from the transition from incandescent to LED lighting as a demonstration facility for lighting designers and manufacturers of lighting, where they could have one space where they could get 50 people from the various cities, and they could see 20 or 30 different solutions in the space of 3 or 4 hours, and then they can all go back to their cities and they can decide what it is they want to do. Because before Doll was here, that wasn't possible. You would need to go out and visit each one of these manufacturers, see their showrooms, and then you're still seeing it in this confined artificial environment. So the idea here with Doll is to not only show these individual technologies, but to show them in situ, so in the real world, and also to show how they can work together. So that's really, really important now, and our main focus now going forward is on interoperability between these technologies. So we're part of a large EU project now called CITCOM-TEF, Cities and Communities Testing and Experimentation Facilities, where it's a European effort to consolidate living labs, technical institutions, knowledge institutions, in terms of how do we share data, smart city data, health data, and these kind of things. So we're looking at consolidating with smart data models, transfer protocols, semantic descriptions of what is a vehicle, what is an air point, and these kind of things. How do we describe those? So then any application that you were to build in Doll you could apply to Barcelona or Munich or some other large city without having to do all of the integration work. Because when we're talking about building a digital twin and smart city applications, by far the largest effort has to go into the integration layer. So that's getting the devices and the companies to standardize what they're putting out, so that we can begin to share and we can make insights across these things. And there we're working with an ecosystem called Fiware, which you can consider a kind of, it's both standardization, so it's transfer standardizations, data models, but it's also a marketplace and an ecosystem where you can purchase AI components that are designed to work with these specific data models and these specific what's called the data space. So a collection of data which has payment systems. It has a kind of legal contractual fundament. So if I want to buy data from you, the data space can handle the payment and generate the contracts. It can make the time bounding effect and so on, and it can also disallow me from sharing data further. So the whole kind of European data space concept is a fundament to this sitcom project, and we will almost certainly be consuming from these data spaces, if not also providing data into them.
Great. And then DAL operates sort of on the standardizations that will be agreed upon for the data, so that any in situ experiments that are done within the lab can be transferred to Madrid or wherever, and they'll still work.
Exactly.
Very, very amazing technology that we're working on. And unfortunately, we are already to the end of our half hour. Any closing thoughts or remarks that you'd like to share with the audience?
I would just like to say that we have gotten quite a lot of use out of our virtual lab, and we are extremely satisfied with the pixel streaming potential. So we're often out visiting people from cities, we're at conferences, we're at other European countries and so on, and it's extremely useful for us to have some kind of portable format where we're able to give a high resolution experience to the person that's observing it. And also one thing that's really important, which I didn't talk about before, was being able to easily simulate scenarios that we haven't realized yet. So being able to import assets into the environment, make couplings between a sensor and a lighting or a traffic light and so on, and being able to test things that would either require closing down a section of the city, having to apply for permission from police and so on, and just generally disrupting the life in the city. We can do those now virtually, and we can demonstrate those to the people that are going to be able to take these hard decisions about, do we buy this technology or that technology, and so on.
Yeah. And we are deeply honored and grateful to be a small part of everything cool that your team has going on. Ben, thank you so much for joining us today, and thank you all for tuning in. I am Quentin Anderson, and this is Real Time Talk with Eagle 3D Streaming. We will catch you on the next show. Thanks again for joining us, Ben.
Thanks, Quentin.
All right. See you all next time. Bye.